To sketch the graph of the rational function, we first factor the numerator and the denominator, find the x and y intercept, find the vertical and horizontal asymptote, graph the information provided with the information provided by the first 4 steps, then plot as many additional points as needed to fill out the rest of the graph of the function. So let's start with the first equation. F of x equals 2x squared plus 7x plus 4. We first will factor out the numerator and the denominator of this function. When you factor it, you should get this equal to 2x minus 1 times x plus 4 divided by x minus 1 times x plus 2. So now we find the x and y intercept. So the x-intercept is the value of x when y equal to 0. In other words, to find the x-intercept, we let the numerator of f of x equal to 0. So 2x minus 1 times x plus 4 equal to 0 would then imply x equal to a half and x equal to negative 4. So let's put that 2 points on the graph first. X equal a half and x equal negative 4. The y-intercept, we plug 0 into the equation f of 0, where f of 0 equal 2. So here is our y-intercept, so that's what we got. Next, we find the vertical asymptote. Well, the vertical asymptote is the value in which the denominator equal to 0. So vertical asymptote, x minus 1 times x plus 2 equal to 0. This implies we have vertical asymptote at 1 and at negative 2. Let's put that information onto our graph. So x equal 1 and x equal negative 2. Next, we find the horizontal asymptote. The horizontal asymptote. The degree of the numerator is the same as the degree of the denominator in this case. So the horizontal asymptote is the quotient of the leading coefficient of the numerator and the leading coefficient of the denominator. So horizontal asymptote y equal 2. So here we get y equal 2. So let's take a look at our table of value and let's talk about the behavior of the vertical asymptote and horizontal asymptote. Okay. So to do that, we make a chart of a table of value of some sort. Okay. So what happened at x approaches something? And here we have two vertical asymptotes, right? So what happened if x approaches negative 2 from the left? At x approaches negative 2 from the right. At x approaches 1 from the left. And at x approaches 1 from the right. And we already factor our f of x to be 2x minus 1, x plus 4, x minus 1, x plus 2, and see what would happen when we put them back all together after backs. So as x approaches to -2 from the left side, x approaches to -2 from the left side, then in this term, that is a little -2 from the left would mean it's a little less than -2. So 2 times a negative number that is a little less than -2 is still negative, and -1 would make this to be negative. Approach -2 from the right, well, it still makes this negative. Approaches 1 from the left. If it approaches 1 from the left, this 1 is positive. You multiply it by 2, it's still bigger than 1. So this is positive, and this is positive. When x approaches -2 from the left and plugs into x plus 4, get this to be positive, 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 and positive. -2 from the left, then x minus 1 going to be negative, negative. Now this is the tricky part. When x approaches 1 from the left, it is a little less than 1. So a little less than 1 and -1, this makes negative. But when it's approaches 1 from the right side, it's a little bigger than 1. When x approaches -2 from the left, then x plus 2 is going to be negative. It's going to be positive, positive, and positive. This means when x approaches -2 from the left, after back is approaching negative infinity, positive infinity, negative infinity, and positive infinity. Okay. Now that we know the behavior of the vertical asymptote, we will go ahead and see if we can use this relationship to sketch the graph. So we kind of know that it will somehow, if it approaches 2 from the left, it will then go to negative infinity. So the graph will somehow look like this on this side. Approaches 2 from the right, it go to positive. So it like this. And to negative infinity from 1. So on this side, it looks like this. And on this end, it would look something like this. Now we need to find what happened in between. Okay. So since we know that it is going to intersect at 2.5, I can tell this part looks kind of like this, right? On this side, I know the graph somehow will look kind of like this. Okay. Now the part that I'm not quite sure is on the other side. So let's take a look at let's pick some value of x and calculate for f of x. Go ahead and pick the value here to be 2 and 3. So 2. When x equals 2, f of x equals 4.5. When x equals 3, f of x equals 3.5. Okay, so x equals 2, we get 4.5. 3, we get 3.5. So it goes in, seems like this is the direction of how the graph will go. So that is the function of the graph of this function f of x. Let's take a look at the next one. We want to get the graph of the function and state the domain and range. F of x equal x plus 2 divided by x squared plus 2x minus 3. Okay. So let's go ahead and factor the numerator and the denominator. The numerator is x plus 2, stay the same. Denominator equal x plus 3 times x minus 1. Y-intercept is the value of y when x equal to 0. So then f of 0 is equal to 2 over to negative 3 equal to third. So that is the value of the y-intercept. The x-intercept is the value of x when y equal to 0. So when y equal to 0, or f of x equal to 0, then x plus 2 have to equal to 0. So x equal to negative 2. So here negative 2. The horizontal asymptote in this case is equal to 0. So y equal to 0. The vertical asymptote, x equal 3, x equal negative 3, and x equal 1. So let's see the behavior of f of x as x approaches the asymptote. If x approaches negative 3 from the left, this means f of x equal to x plus 2 divided by x plus 3 times x minus 1 is approached. So if x approaches negative 3 from the left, x plus 2 is going to be negative. X plus 3 is going to be positive. X plus 3 is going to be negative. And x minus 1 is going to be negative. So this is going to negative infinity. Negative 3 to the right. X plus 2 is going to be negative. X plus 3 is going to be positive. And x minus 1 going to be negative. So it's going to be positive infinity. X approaches 1 from the right. X plus 2 divided by x plus 3 times x minus 1. X plus 2 going to be positive. 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 So going to positive infinity. X approaches 1 from the left. Then x plus 2 divided by x plus 3 times x minus 1 is going to be positive, positive, and negative. So this is negative infinity. So we gotta know that the graph kind of have to look something like this as x approaches negative infinity. As x approaches negative 3, then we go to negative infinity. So it's something look like this direction. 3 from the left, 3 from the right is this direction. 1 from the right. 1 from the right is going to be positive, and 1 from the left is going to be negative. Okay, so this shape is kind of look similar to the one that we have earlier. Let's pick some value to figure out what happened in the between. So let's start with x, f of x. So let's say negative 4, negative 3. We already know that 3 is this asymptote. So negative 5, negative 4. Okay. So we get here that is negative 1/4, negative 0.4, negative 0.25, 0.8, 0.42, 0.3. So let's take a look at the graph. The y-intercept, this is 2 over negative 3, that is negative 2/3. Okay, so in this side, negative 1, we get negative 0.25. So it look at it something like that. So the graph look like that on that side. Okay. Negative 5 to negative 4. So that telling us this graph gonna look like this branch over here. And on the other branch 2 we get 0.8, so close to 1. 3 we get smaller. 4 we get even smaller. And we know that as it approaches x equals 1 from the right, it goes to infinity. So here is the graph of f of x. Okay, so f of x equals to x to the third minus 2x squared divided by x minus 2. So first factor out the numerator. And we simplify this. Note that here we have the denominator x minus 2. This only telling us that the graph has a hole at x equal 2. So f of x now, I can simplify this to get x squared. So we know this graph what it looked like. We do know that the graph have the hole at x equal 2. So at x equal 2, y equal 4. So this graph have a hole right there. So this is the graph of f of x. And the domain here is from negative infinity to 2, union with 2 to positive infinity. The range, because we have a hole here, is 4. But we plug in the hole over here. So the range here is all real number. So negative infinity, the range here is going from 0 to positive infinity.